Today we are designing WhatsApp's View Once feature. Before we write any code, we need to agree on the rules. First, privacy. We need a system where the server acts like a storage locker, but it doesn't have the key. We call this zero knowledge. The server holds your file, but it cannot see what is inside it. Second, one-time access. This is the hardest part. The file must be opened exactly once. If you view it, and your friend tries to view it a second later, the system must block them. There are no half views, it's all or nothing. Third, speed. Users won't wait 5 seconds for a photo to load. It has to feel instant. And finally, destruction. When the timer runs out, the data shouldn't just be hidden, it must be unrecoverable. Let's look at the high-level architecture. A common mistake is thinking the photo travels inside the chat message. It doesn't. That would be too slow. Instead, we split the system into two parts. One is the blob storage. Think of this as a giant hard drive in the cloud, like AWS S3. This handles the heavy files. The other is the chat service. This handles the small text messages and notifications. When you send a photo, you aren't sending the file to your friend. You are uploading the file to the hard drive, getting a unique link, and then texting that link to your friend. But wait, if the server has the file, can't the server see the photo? Let's fix that. This is the secret sauce, hybrid encryption. Here is how we keep the server blind. Before your photo leaves your phone, your app generates a random password. We call this a symmetric key. Your phone uses this key to lock the photo. Now, the photo is just a scrambled mess of data. We upload that scrambled mess to the server. The server has the file, but it doesn't have the key to unlock it. So, how does your friend get the key? We send the key directly to them inside the chat message. This message is protected by WhatsApp's standard end-to-end encryption. So, the server holds the locked box, but only the receiver gets the key to open it. To keep track of everything, we need a database. We likely use something like Cassandra or DynamoDB because they are very fast at writing data. We need a table that tracks the message status. The status changes from sent to delivered, and finally to opened. This status field is our safety switch. Once that status hits opened, the system locks down. No matter what happens next, the server will never let that file be downloaded again. Let's walk through the actual API calls, the messages the app sends to the server. First, the sender uploads the encrypted file. The server replies with a URL, basically, the file's address. Second, the sender takes that URL, combines it with the secret key, and sends it to the receiver. Notice one important detail: we also send a hash. A hash is like a digital fingerprint of the file. When the receiver downloads the image, they calculate the fingerprint again. If it doesn't match the one in the message, we know the file was tampered with, and the app rejects it. Now, here is a tricky engineering problem: race conditions. Imagine you try to open the photo on your phone, and at the exact same millisecond, you try to open it on your laptop. In that split second, the server sees the message is still unread for both requests. If we aren't careful, both devices might download the image. That breaks our view once promise. To fix this, we use a conditional update. When the database tries to update the status to opened, it checks a condition first: is this message currently unread? Only one request can pass this check. The first one wins and gets the image. The second one fails immediately because the status changed a microsecond ago. Finally, we have an edge case. If the server can't see the image, and the image deletes itself, how do you report abusive content? We have to make a tiny exception to our rules. When you tap report, your phone takes the image from its temporary memory and sends it specifically to the moderation team. This happens before the deletion runs. It basically says, I know this is private, but I am explicitly giving permission for this specific image to be reviewed for safety. Once sent, the standard cleanup wipes the evidence from your phone.